So definitely will all your questions will be answered, but in the due course. Okay, exactly at the timing. Okay, based on the coverage. Okay, don't worry. Uh, if you want to learn more, or if you want to learn out of this particular thing, what we are discussing, you're absolutely that is absolutely required. And of course, I will be available to you for the session. Just post your queries or interact with me. Definitely will take it forward. Now, one more important thing is just we'll see some sort of other things like some other applications, like some simple aspects before going ahead with the functionalities of RDD and understanding of the transformations and actions. I want to give some little programmatical aspects in the RDD, because RDD up to now, uh, you can have the identification of the RDD, creation of the RDD with collections or with range, or else loading your RDD with respect to some sort of the existing data, and storing the data and picking up the data. Up to now we have seen. Now there is a file. So where just I'm going back, and here I'm selecting file store. Just within that file store, we're having the tables information. There I'm having some sample data. Okay, so sample.csv. I want to load this particular data, friends, actually. So just I'm clicking this so that I will be getting the appropriate path. Just I'm copying this particular path. Okay, so what I'm doing here is just I am making use of the convention, like, so just if I want to pick this data text file. Okay, now earlier we have seen some sequence file. Okay, so now we are seeing the text file. Periodically, we are going to talk about the JSON, CSV, all these kind of the conventions. Okay, now I am pasting this path. Okay, so now after getting this particular information, now I want to store in some kind of the RDD, number of lines related to the line RDD, something like that I want to store. Okay, now just you type what exactly the type of the data. Okay, it is basically RDD, because we at the moment we are using this Spark context kind of thing, and whatever the file you are using, just you are making use of the convention. Now observe guys, whatever the way we are working with the RDD, because this RDD is the launch pad for the high level APIs. That means working with the data frame, understanding of the data frame, all these things are dependent on this RDD understanding. Now line RDD, okay, whatever I'm having, just let us see the content, because earlier we have seen some simple content. Now I am having some sort of the data where that particular data is giving some this thing, actually timestamp, age, gender, country, state, self-employed, family history, treatment, work interface, interfere, and no number of employees, remote work, tech company, benefits, care option. And well, like that, we're having some sort of information. And accordingly, just we are having this information. And I want to get some sort of number of records or length, some operations I want to perform. At times, I want to manipulate the data. Okay, but plenty of opportunities are there for the data pre-processing, especially on the data frame orientation. But to strengthen our understanding of the RTD, I want to scope this access of the data also. Okay, right. So we are having some sort of the data with us. Now, friends, here, if you observe the collect method, have a look on this collect. What it does is returns a list that contains all of the elements in this RTD. Okay, all the elements. Okay, without any filter or without any thing. Just I want to collect the entire information. But sometimes, there is a number of records. Some million records would be there in that particular case. Is there any other option to pick up that particular data? Yes, we do have, like line RTD dot. Rather than using collect, there is a method called take, and I want to take the 10 records. So this thing just gives that narration. And if you see the functionality of this thing. Take the first number of elements given by the user of the RDD. Okay, so and one more important property you can see here, guys, as some of our friend asked that partition kind of thing. Let us have a look on this. It works by first scanning one partition and use the results from that partition to estimate the number of additional partitions needed to satisfy the limit. So take functionality generally helps us, guys. Uh, just it is picking up a kind of the partition and it is going to map with the appropriate number of records. Accordingly, it is going to compute. So take is a kind of the functionality where this method should only be used if the resulting array is expected to be small, as all of the data is loaded into the driver's memory. See, these points are pretty important, guys. Okay, because in terms of the collect, it is giving the entire information, but whereas in terms of the take, you are restricted to work with the smaller set of the data items. And this entire data is available into the driver's memory actually. But if you go back and verify the collect methodology, just to click on this collect. Okay, just this method should only be used if the resulting array is expected to be small, as all the data is loaded into the driver's memory. Okay, so there is a distinction actually. Be pretty sure that if you need to use the collect or take, take you can specify the appropriate number of records. Okay, maybe 10, 20, 30, and make sure that even sorry, that number is also reasonably good. Whereas in terms of the collect, we don't have that option because the overflow kind of the errors and because we are working with the in-memory kind of the computing, that too this the edition is also Databricks community edition, so that there are certain restrictions. And even you can realize in some of the job submissions, it takes some longer time. Of course, I'll compensate with some explanations and all, but still we need to wait up to 5 to 6 minutes also, where that is not the case in terms of proprietary editions. Okay, these kind of distinctions were there. Otherwise, the usage and functionality and coding are as usual without any problem. Now there is a one more option. Just I want to find out the length. So whatever the records I'm having in the RDD, just I am mapping, and mapping definitely associated with the lambda function, and whatever the value I'm having, just I am putting the length. So after getting the length of that particular record, okay, it is applicable to all each and every record. Now I want to find out the total length, which is nothing but each record, whatever the length I'm having, reduce. I'll explain this thing, friends. Reduce lambda. Okay, so lambda function, sorry, lambda function, and as well as whatever the values I'm taking. See here, friends, the way how we are doing the lambda is pretty simple. Just we're adding the numbers, total kind of the count. Okay, just if you consider, let me see. Yeah, if you consider the reduce the elements of this RDD using the specified commutative and associative binary operator, currently reduces partitions locally. So the functionality of the map, okay, somehow map is not, yeah, map returns a new RDD by applying a function to each element. So it is just giving the return statement in such a way that in terms of RDD. But whereas your reduce, guys, just what it does is reduces the elements of this RDD. Of course, it is doing that using the specified commutative and associative binary operation, and currently reduces partitions locally. So and moreover, if you consider these kind of thing, and if I want to add, okay, reduce dot add these kind of the things in a commutative way, and if you are making use of the range functionality along with the caching, and as well as if I want to reduce those kind of the things, you can use the reduce kind of aspect. So reduce is something which is giving us some sort of action, okay, which is performing some kind of the activity. Now, if you consider the total length, okay, obviously it returns some kind of the number. Okay, those many records we're having, and all those kind of the numbers can be used with the usage of whatever the functionality you want. Okay, based on the resultant. Now the one more point, guys, actually, how many of you are knowing about the key value pairs? What is the use? Of course, one thing is the dictionary. One thing is the dictionary. Other than the dictionary, friends, can someone help me? Where do you observe this key value pair kind of the functionality? Key value pair. Can we add multiple data with different formats? Of course you can. Okay, like A is integer, B is float kind of the things. Yeah, there is no restriction on data type, friends. Okay, typical lambda function only, na? There is no kind of whether you are using the map or reduce kind of thing only it focus. Otherwise, all other functionalities are similar. That's what I'm saying. Otherwise, explicitly mentioning the restriction of the data types in all the other cases, whatever the way you are adding your numbers, but there is a restriction. I cannot add string and integer, string and float because first I should convert that float into the string, then I can concatenate. Those basic things are remain same, guys. Okay, that and all common. Only the restriction is other than the logic. If you want, if you are using the map or reduce by key or count by key, yet to see many we need to see. Just this is nothing but I want to introduce RDD, and even RDD is very low level kind of the functionality, but still we are able to apply some transformations and actions. Okay. Now, other than the dictionary, actually, yeah. Very good, Anurag. Jason, Mayur, Jason. Elias says SQL, SQL key value pair, hash map and JSON. Because, you know, friends, key value pair is most common functionality in terms of the map reduce also. If any members are having the inclination of map reduce orientation, the basis for that map reduce is a key value pair. And even in Spark also, we are having the key value pair kind of the data so as to compensate the working of the MapReduce aspects. Okay, of course, MapReduce is not the scope of our study, but still here and there we are picking up some kind of the Hadoop based functionalities because both the Spark and Hadoop comes under the genre of the big data. Okay, so obviously we need to refer those kind of the functionality. Uh, in case of machine learning, how we are going to refer the data engineering kind of thing, loading of the data, or else if you are making use of the convention like where how you are mentioning the usage of data pre-processing like missing value imputation, encoding techniques, feature engineering, the same thing can be replied in the machine learning also. Okay, so likewise there are certain aspects, guys, where we cannot avoid referencing those points instead of along with our current discussion. Okay, now similarly, just we are making use of the key value pair just as an example, and then we'll jump into the other discussions. Actually, I need to discuss partition, and then I'll be talking about the transformations and as well as this thing actually actions. Many are there, guys. Just we'll talk about some of the transformations where we use most frequently, right? Okay. Now, if I am specifying the key value pairs, what I'm doing here is that is a key value pair kind of the notion. We'll be taking line RDD, whatever the initial data we are having, and we are using the map functionality with lambda along with the simple thing like s comma 1, whatever the string I'm having, just I'm maintaining the key value pair. Now here also I want to count the appropriate values. Okay, along with that pairs dot. Okay, so one more functionality, reduce by key. Okay, this time this reduce by key is nothing but maybe suppose I'm having data engineers, some 1,000 members, data scientists, some 2,000 members, data analysts, some 3,000 members, and I want to reduce the corresponding values based on the key. It is something like, guys, group by kind of aspects where I want to perform some sort of the activity based on some kind of the functionality. based on the designation or qualification or state or country, whichever. Okay, reduce by key. And here also just we are using the lambda functionality in such a way that so just we'll be adding these kind of the conventions. And here uh, see the same logic, guys. If you consider this logic, and here we have used reduce accordingly, it is going to perform the logic. Some people ask that in the map also we are writing the code, in reduce also we are writing the code, and reduce by key also we are writing the code, and it is done by the lambda only. Then what is the performance of this reduce by key? Here I can defend you guys, like though the same logic I am writing in the lambda in both reduce and reduce by key, here reduce is not doing any separation of the keys. Okay, just it is adding all the values, and we are getting this double to 0, 5. Okay, sometimes we may get the same outcome for the reduce by key also. When we'll get the same outcome for both reduce and reduce by key, friends? Simple, if the values are unique. If all the 2205 entries are unique, then there is no other gonna, it cannot add the values. Whereas if any repetitions are there, then it is going to uniquely separate those values, and accordingly it is going to uh, add the values based on this convention. So though in reduce I have used the same logic, it refers to addition of each and every word. Whereas if you are considering this thing, just after splitting these things, what we are doing here, guys, just based on the uniqueness of the values, we are separating those particular entries. Accordingly, this reduce by key is going to add. Now, if you observe this functionality, okay, reduce by key, just some functionality. Partitions we have to yet to see. I'll introduce. And what exactly this thing is, merge the values for each key using an associative and commutative reduce function. This will also perform the merging locally on each mapper before sending results to the reducer. Similarly to a combiner in map reduce. I'll talk about these things, friends, in a while, because mapper, reducer, combiner, all these are the functionalities which are really helping us in the Spark also. And there is actually, as I said, there is a complementary aspects. So some of the properties of the Hadoop really help Spark in terms of the memory, in terms of the storage, in terms of the distribution. Whereas Spark gives complement to the Hadoop in such a way that with optimizations, a lot of optimizations are there in the Spark, like in terms of MLlib, all these kind of the functionalities. So if you combine these two technologies as a single cluster, and if you want to run the jobs, then it is a deadly combo, guys, no doubt about that. And output will be partition with a number of partitions or the default parallelism level. If a number of partitions is not specified, default partition is a hash partition. So just we're having some sort of the numbers here for the simplicity. You can see, guys, A is occurred twice. So obviously A comma 2, B comma 1, because reduce by key always focus on commonality of the key. And however, we separated our data based on the key value, and based on that particular key, if I want to perform some kind of the activity, then I can go with the reduce by key. So this I strongly recommend, guys, please use the documentation. Okay, of course, in the session itself, we are having the clarity, but still the terminology wise. Okay, the terminology wise to pick up the Databricks or Spark kind of the terminology perfectly, because while talking in the teams or while working with your clients, if you are using these kind of the terminology in the calls and all, definitely they can also believe us, because from the subject and from the experience, our vocabulary will definitely change. So as to pop up these kind of functionality and to build the confidence. Okay, even some of the team members explicitly, um, I mean, the clients are specifically asked for those team members, and my wish is also you guys also need to reach to that level. And of course, I am sure some of the members are already there, where clients will definitely appreciate them and would have appreciated them, or clients want those kind of the people in the upcoming projects also. That is real happiness for us guys. If you are dealing with some of the projects or if you are dealing something, and if client is really happy and clients are coming back to our manager and clients are saying some so and so guy definitely required for the future project also, then that is a real success, right? Along with the appraisal, that is understood. So now if you consider these kind of the functionality, let us shift enter. And after that, just you can make use of the counts. Just I am giving the collect method. Okay, so you can make use of this collect. Okay, so surprisingly, it is giving the outcome. Okay, so is there any repetition is there, or if it is not repeated, then it simply gives one. So that's what friends actually the timing also it is reduced by key to 0.19, whereas if you consider the reduce, it has taken 0.68. Okay, in either way, if the values are repeated, if the values are not repeated, in either case, your reduce by key is taking less amount of the time. Okay, and now onwards, guys, just to have a look on this convention, like estimation of the time is also most important. Okay, just to habituate, maybe in terms of this kind of things, this particular command actually taken collect method has taken 2.49, whereas this particular collect where if you consider this value, we have not taken any collector, just we have directly printed. It has taken only 0.15 seconds. So here and there, those kind of the distinctions are there. But my strong recommendation will be, suppose if you are running the appropriate aspects parallelly, and if you are using multiple functionalities on the same data, on the same environment, okay, provided, then it is always preferable to have a look on the timing also, because one of the best thing with Databricks edition is it is providing us some sort of timing, all these kind of the functionalities. Otherwise, you have to go back to this particular job queue, and there you need to verify the convention, how many stages are there and all, and go to this view, and accordingly you can estimate the kind of the operations, how much space and how much time it has taken. But now you see guys here, if you consider the kind of the functionality here, so just we are having the DAG here. In the earlier diagrams, we got only few aspects, few functionalities, but now it is having multiple stages. Okay, so accordingly, just if you click on this, okay, it's not allowing, but it's okay. So, but if you are making use of the job functionalities, okay, here itself, you can realize that the DAG, it is splitting the appropriate tasks, and we are going to perform some kind of the activities individually also. If you are clicking the stages, all the functionalities you may not get, guys. That is again one more glitch with the community edition. Okay, and likewise, there are some certain points where you need to observe in the understanding of performance benefits, guys. Okay, again, actually, our interest is to study about the transformations and as well as actions. So for that particular purpose, I'm having this. I've collected the details, guys. RDD, yeah. So these transformations, uh, as of now, just I have not explicitly mentioned what is. Just I'm talking about the operations only related to the RDD, but there is a distinction between the transformation and as well as the action. So as said earlier, your transformation is nothing but lazy evaluation, and until you are performing the activity, it is not going to activate. So to notify that, uh, just to observe this point, guys, uh, I want to pick up this particular file where sample.csv. Let me show you one underscore, rather disturbing this thing. What I will do is I'll copy this and I will run this particular thing. Okay, now what I'm doing here is definitely this thing, this file is not there. Okay, just I'm running this file, guys. Oh, sorry. Cluster is not that easier. No? Attach and run. Okay, we are in on the other page actually. Okay, so no problem. What I'm doing here is just I'm picking up this data and I'm making use of this functionality. Now I am changing the file name. Definitely new underscore sample is not there. To clarify that, go back, file store. Okay, within the tables, there is no new underscore, something like that. Okay, only we are having the sample. Okay, all these kind of the sales info like that. Now observe here, just I am running this command shift enter. Nothing, no error, nothing. But at the moment, I am making use of line RDD dot collect. Now you see what it is saying. Invalid input exception. Input path does not exist. So whenever you are performing some action, whenever there is a need of pulling out some records or some results, then only our RDD or our Databricks or our Spark is returning the error. Here, even it is not bothering about what exactly this guy is doing. That is what you call the lazy evaluation. Okay, so lazy evaluation in the sense, though whatever the functionality you are giving, that functionality is not executed. Later, whenever there is a dependent action is required, then only they are going to execute. That is how you can see the functionality of the transformations. Okay, so just the many transformations are there, guys. Here, Databricks provided some of the transformations like map we have seen returns a new distributed data set formed by passing each element of the source through the function. Lambda function generally we have used. And filter, as the name implies, just we are going to specify some of the conditions. Flat map, similar to the map, but it is making use of, okay, just input item can be mapped to 0 or more output items. Map partitions, okay, and map partitions with index. Sample data out of the existing number of records, I want to pick up some sampling, okay, with replacement and all. Union, intersection, distinct values, group by key, reduce by key, aggregate by key, sort by key, and join operation, go group, Cartesian, pipe, coalesce, which is most frequently used operations in the partition, repartition, repartition, and sort within partitions. All these things are belongs to the transformations. Okay, so maybe immediately you may not getting the convention of how do I remember these things, friends. Don't worry. I never support any by hearting. Okay, no need of by hearting or nothing. Okay, so just you based on your experience and based on your capabilities, skill set. Okay, accordingly you over the period justify. I'm asking whether this is a transformation or not. Just you can with your experience after 3 or 4 days of using the transformations, you can proudly say, yes, this is the transformation, or no, this is the action, like that. Okay, don't worry about now, but just I'm giving you the kind of the functionalities where these are all belonging to the aspects of the transformations. Now, uh, if you are making use of other way around the actions, now in the example itself, the transformations are lazy, even though some issue is there in the path or something like that, it is not going to reply or respond any error or erroneous kind of the situations. But whereas whenever there is the action, definitely this action should go back and run this particular transformation. Then only it is going to realize, okay, it is going to fetch the appropriate data. If this transformation is successfully completed, then only based on the resultant of the transformation, the collect method is going to work. Otherwise, if any issue is there, if any problem is there related to that particular activity, then your collect method, your method is going to return not only collect anything, take if you are taking or if any other actions you are taking, all these kind of the things return the error, provided if any of the corresponding transformations are having some error. Corresponding, I'm using the word corresponding in the sense maybe all the transformations may not be relevant to the action. Assume that I have used some 10 transformations and 2 actions in my code. Maybe one action related to 6 transformation, another action may be related to the 4 transformations. So these 4 transformations are not going to return any error or not going to execute whenever the first action is performing. So it all depends, na? Like while running the code, maybe some of the actions are definitely relevant to some of the transformations. Accordingly, the Spark is going to raise the error or skip the corresponding things. Now coming to the actions, just this action uh, is depending on the transformations, guys. Action should trigger immediately. Okay, because that action is something like which is performing some sort of the functionality, maybe finding out of the length or count or take or save as kind of thing. Okay, because there should be some proper outcome, proper functionality. So then those kind of the aspects comes under the category of the actions. Okay. Now some of the actions, reduce already we have seen, collect we were seeing, count also you can observe, returns the number of elements in the data set, first element. Okay, so and take also we were talking about, and take sample. This is also action. Take ordered, save as text file, and save as sequence file. This also we have observed, and save as object file. Count by key for each. Okay, these are all some of the functionalities where you can refer the operations in terms of the actions. So simple distinction, guys. Transformations are lazy in the evaluation, and they are not going to immediately fire. They are not going to execute immediately. Coming to the actions, out of these particular things, maybe the reduce, collect, count, first take sample, take order, save as text file, sequence file, object file, count by key for each. All these kind of the operations definitely require some sort of the functionality, where they need to trigger, execute the activity. Most important topic is shuffle operation, guys. Okay, because there you need to distinguish between the narrowness and wide kind of the transformations. Okay, so now just if you consider the appropriate transformations, now we are focusing on each and every aspect, how these sort of the transformations, how we are performing some sort of the activity is a typical story behind this, guys. Okay, related to the transformations and all these kind of the conventions. Now there is a definition, as I said earlier. We need to depend on 2 aspects. One is the Apache Spark and second is the Databricks documentation, because this is the evidential as we are studying Spark. Why we need to study these two? Again, I will come back to that question. Reason is Apache Spark is the promoter of the open source of the Spark, whereas Databricks proprietary kind of the aspects and all the research. Of course, from Apache and from Databricks, there is a integrated research, guys. Okay, and however, all the updates, all the point of contacts uh, going through this Databricks only, so that we can dependent on this Databricks for the functionalities which are advancement, something like that. For the documentation and all the kind of the examples, we can go through the Apache website also. Okay, right. Now the transformations. Now we are able to define what exactly the transformation and what do you mean by narrow dependency? What do you mean by wide dependency? And we'll come back to the partition discussion once this thing is over. Very simple, guys. Don't worry about 3 or 4 lines. Absolutely simple. What are transformations? In Spark, the core data structures are immutable. Core data structures are immutable. Now let me know, friends, what do you mean by a core data structure? Core data structure.
It's RDD.
It's RDD, exactly, right? Okay. Core. Core part is a Spark RDD API are immutable, meaning they cannot be changed once created. This might seem like a strange concept at first. If you cannot change it, how are you supposed to use it? Why I love this documentation is, guys, it's a typical developer mindset, because always the developers like Surinder and who has asked the question to me, Nisha. and some other, yeah, Dharma Surya. Okay, all these guys having a typical developer mindset, because we have to question, guys, definitely whether that question is. Of course, I always support the questions related to the discussion. Maybe in our meetings also, we need to ask the questions. If we are not getting the what the essence and what exactly the requirement, then it is we are unable to implement the aspect. So definitely we have to question. Now the thing is here, the way how these documentation has been designed is they think like us. Okay, they think like us, then they process like us, they talk like us. Okay, like okay, they will put some topic and they will question and they will give the clarification. So now the point is, if the things are not changeable, then how do I update that? So in order to change a data frame, you will have to instruct Spark how you would like to modify the data frame you have into the one that you want. Your responsibility is how means whether you want to filter, whether you want to find out the maximum, or whether you want to add, as someone asked me, like can I add integer or float in the same kind of the thing. These kind of aspects you need to mention as how. Okay, you need not worry about what and where, all these kind of the conventions. So these instructions are called the transformations. Okay, one thing is pretty clear. Your RDD or data frame, we are unable to change directly because they are immutable. But what you can do is, as a developer, as a Spark practitioner, you can mention whatever the operations, whatever the modifications you want. That is exactly the transformation. What do you mean by transformation, guys? Like, earlier, all of us joined as a basis kind of thing, and then over the period of our experience we transform into many subjects, and then we'll be engaging with future projects like that. That is what you call the transforming. Like similarly, the transformation also, whatever the data you are taking and you want to transform that data, you want to get some outcome out of that particular source data. So these transformations are core of how you will be expressing your business logic. See how cute this particular documentation, guys. Without any by hearting, without just you can say that transformations as our data items are immutable. We need to still we have to use that particular change, and we need to specify how. So the transformation allows it takes care about how part, and it is enough to mention how and where and what will be taken care by the transformation, which is nothing but the mentioning of the business logic according to the requirement. Now the point is, and in what way these transformations are working. There are two things, guys, very, very representative and very, very required for our development. Narrow dependency transformations consisting of narrow dependencies or narrow transformations are those where each input partition will contribute to only one output partition. Have a look on this, guys. Narrow transformation. Just I'm having the partition. Okay, is a data kind of thing. Okay, each input partition will contribute to only one output partition. Correspondingly, just they are making use of the convention like one input and corresponding output. Whereas your wide. Okay, very, very important thing, guys. There we are using the term called shuffle. Believe me, guys, this particular shuffle term reflects in the repartition, Polish property, white transformations, and shuffle I can observe in optimization techniques. And it becomes a standard, guys, like, because the shuffle operation is more expensive, very much expensive, guys, like like in SQL, if I'm talking about the joins is there na, like in Java also we are having pretty higher end kind of the implementation where expensive. In Python also, like list and all these things rather than arrays. Array always took less time when compared with the list, because array only focus on a homogeneous kind of the data, whereas my list is focusing on heterogeneous. Obviously the time and as well as other kind of the infra requires more in terms of the list, whereas in array it's not like that. So here the widest methodology of this transformation is a wide dependency. A wide dependency, or which is also known as wide transformation. Transformation will have input partitions contributing to many output partitions. If you observe this diagram, one input partition is uh, taking part in all these three output. And second also almost it is also taking part in all the output. So like sorting mechanism, arrangement of the things or join mechanism, because the join or sort cannot be fit into a particular stream. Maybe I'm having my records in first partition and second partition. There is a possibility of exchanging the data. Okay, so moving of the data, because this particular shuffle exchange partition, you will often hear this referred to as a shuffle, where Spark will exchange partition across the cluster, which is a dangerous act, friends. Which is a dangerous act, because across the cluster, if I'm consuming the resources left and right, I'm using my cluster. So definitely you are pushing the appropriate operation. That's what while using the transformations, be cautious whether we are insisted on the time factor or space factor. Two things. Time factor means never mind. You can use lambda functions or whichever. Space factor means definitely you have to restrict yourself. Okay, avoid usage of this wide dependency. Maybe you need to hand code the appropriate functionalities, right? Okay, so with narrow transformation, Spark will automatically perform an operation called pipelining. Okay, or narrow dependencies. That means, friends, narrow transformation is a typical sequence where there is no hassle of shuffling and all. This means that if you specify multiple filters on data frame, they will be performed in memory. The same cannot be possible in terms of the shuffle, obviously, because the shuffle is something like where it is exchanging the data and it is pointing to various input partitions. Now the point, guys, here. So just if you observe the highlighted part, when we perform a shuffle, Spark will write the result to disk. Most dangerous situation. We are against to the Spark philosophy, because Spark philosophy is in-memory computing, ease of use, and process, and all these kind of the conventions, developers view like data engineering or data science kind of the aspects. So at the moment you are making use of the convention, guys, it is writing the results to disk. Why it has to write the result to disk, friends, whenever the shuffle is performing? Can someone help me? What is the reason behind that? Because up to now, maybe in terms of the narrow transformations or in terms of the RDDs or actions, we never felt that okay, something is going to return to the disk. Whereas in distinction also, with there we have seen that in your Hadoop based kind of the ecosystem, everything is a disk based operation, and which itself become a kind of the barrier for the developer who want to use the Hadoop, because he cannot tinker those many hard disk kind of thing, and he cannot bear that amount of the time while performing the processing. Whereas in a convenient way, we can adopt our Spark, but still in Spark we are getting this kind of the convention. What to do? Simple, like whatever the activity you are performing. The point here is, guys, at the moment your random access memory is spillover or overburden in the sense full occupancy, then it has to see the alternative. Okay, like memory and disk with persistence, memory and disk with serialization. Excellent topic, guys. Storage levels. Okay, so it follows like all dependent this thing, guys. That's what I'm saying. Don't miss out the sessions, because at least up to 1 week. Up to 1 week. Reason is as we are talking about the solid core concepts of the Spark, these core concepts are having the strong roots among the partitions, and then optimization techniques, and thereafter usage of the UDFs, broadcast variable, accumulator, usage of the narrow and wide transformations, actions, all these kind of the conventions. So again, I'm repeating, when we perform a shuffle, Spark will write the result to disk. You will see lots of talk about shuffle optimization across the web, because it's important topic. But for now, all you need to understand are there are there two kinds of the transformation. So because this is the one which is really killing the efficiency of the Spark. Okay, be careful while using the wide transformation kind of thing. And of course, optimizations now it is not required. Periodically, we'll go and have a look on this particular kind. Now, So just to as a kind of the task, guys, what I'm giving here is let me share the OneNote so as to conclude the session too much. Okay, so just let me talk about the key takeaways of today's session, guys. Uh, just I want to consolidate these aspects. The very first aspect is how we have started and what exactly our things. Um, Let me give you the key takeaways. Okay, the very first thing is we started our discussion related to RDD API, which is a low level API. Second thing is, guys, just we talked about RDD create with parallelize with text file and then with the sequence file. And then we have seen some sort of, guys, range function. And then we have observed the map, some sort of reduce by key. And then uh, collect some sort of take, save as sequence file, save as text file. Like that, we have seen some of the aspects. Now, latest, we were discussing about the transformations where I'm having the concept of the narrow and wide transformation. Okay, no shuffle. And here I am having the shuffle operation. No shuffle and shuffle. So, and along with that kind of the conventions, a list of transformations I have given. Okay, and then we are talking about the actions. Now the tasks of the day. The very first thing is RDD relationship with the Spark context. Second thing is partitions I have not covered due to the time constraint. And of course, in the next session, we'll see all these kind of the things. And thereafter, transformations. In this, just to have a look on narrow and wide transformations. Second thing. And third aspect, guys, have a look on the actions. This much is enough, guys. I don't want to kill your weekend. You enjoy, no problem. So, but just to have a look before logging off for today, just have a look of these RDDs, Spark context, transformations, and actions. And coming to the next session. Okay, the first topic is I need to discuss about map. We left with this reduce and combine. While talking about that thing, I missed out this thing. I'll introduce those aspects, guys. Second important discussion is partitioning and leftover aspects with RDD like accumulator topic and as well as the broadcast mechanism. Okay, so these things, of course, to give a glance, because some people may be interested to study and come to the session. So that I am giving the avenue of those kind of the members also, so that you can have a look on that as a prerequisite and then you can travel with me. Otherwise, no problem. If not, time is not permitting, so that you can be with me, I can take care. I will take care about that. Okay. So this is how we have done our session today. And let me see, is there any doubt or any kind of thing? When main memory gets full, of course, very good. Bharadwaj, Asrlosen, data is distributed across multiple partitions. Very good. Mayur says out of memory. Yeah, Surya says to keep order. Somewhat near. Yeah, because the shuffle and all these kind of things, it's not a one day deal, guys. It is a burning problem for the designers, actually. Okay. So with that, we can close the session. I don't want to overboard you. Okay. Thank you. Thank you very much. Have a nice weekend, friends. Meet you with the nice aspects of the next week session. And partitions be really helpful to us. Accumulator and broadcast really comes with optimizations, and then the other models of the RTD. And probably I'll introduce you the concept of the data frame also. Okay, that's all, guys. Thank you. Maybe if you are not getting doubts now, maybe while going back and see the appropriate recording, and if you memorize the things, if you still not having clarity, then please ping me so that we can have a discussion. Okay, thank you, guys. Thank you very much. See you back.